right. Hey y'all, Mr. Kyer, Mr. Kyer, Mr. Kyle, and let's just jump into it. Let's look at number 39. Determine whether the sequence defined as follows has a limit, and if it does, we're gonna find the limit. So the first term is 3, and then we know recursively what's happening after that, and that is for n equal to 2, 3, dot, 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 which I'm not sure why they're letting us know that, because that is normally what we would do with n values, is we would count them, like, like just count all the natural numbers going to infinity starting at 1. So that's kind of weird how they're writing that, but hey, let's just roll with it. So when n is 1, a sub n is 3, and then when n is 2, then a sub 2 would be equal to 2 times a sub n minus 1, which would be a sub 2 minus 1. Right? So then that would be a sub 2 is equal to the square root of 2 times a sub 1. That would be a sub 2 is equal to the square root of 2, which we can actually just yank that out. The square root of 2 times the square root of a sub 1. Ooh. Okay. So the square root of 2 we know is about 1.4, and if it was just being times by the square root of 2, then we could write that pretty easily, explicitly. But let's see. So a sub 1, we know what a sub 1 is, right? A sub 1 is 3. So this is times the square root of 3. Okay, not too bad so far. What about 3? So then that would be a sub 3 is equal to, I'm going to go ahead and split that square root of 2. Square root of 2 times a sub 2, right? So square root of 2 times what's a sub 2? A sub 2 is the square root of 2 times the square root of 3, which is the square root of 6. But I'm going to leave it fairly unsimplified just for right now, just so we can start looking for patterns. So we'd have this, which is this times the 4th root of 2 times the 4th root of 3. Okay, this is actually going to be really similar to the previous one we were working on. So a sub 4 square root of 2 times the square root of all that. So the square root of the square root of 2, the square root of the 4th root of 2, and the square root of the 4th root of 3. It's getting pretty crazy over here, guys. Okay, a sub 4 square root of 2, 4th root of 2, 8th root of 2, and the 8th root of 3. If only we had started with something else, like a 2. Like if we had started with a 2 instead, then maybe. But that seems to be the pattern. So this pattern is actually super similar to the one we just worked on. We could write this recursively then for some arbitrary n value as a sub n would be equal to, or actually, you know what? Recursively. Why am I saying recursively? We already have the recursive formula. Oh, but you know what? We could rewrite it recursively though. We could write it so. Yeah, let's do that. Let's actually do that. So this would be 2 to the 1/2 times 2 to the 1/4 times 2 to the 1/8 times 3 to the 1/8. This would end up being 4/8 plus 2/8 plus 1/8, which is 7/8 3 to the 1/8. This previous one would be 2 to the 1/2, 2 to the 1/4, 3 to the 1/4. So that's going to be 2 to the 3/4 3/4. It's supposed to be a 3. Times 3 to the 1/4. So we can actually write this recursively maybe a little bit better. This would be 2 to the 1/2 and 3 to the 1/2. So maybe a good way to write this would be, it's essentially, and I'm going to write this loosely because like I said on the last one, writing these explicitly would be crazy. So we're just going to write this loosely, like what the pattern actually is here. Okay. So essentially what's happening is for a sub n, it's going to be 2 to the power of, and then it's going to be basically, you have for the second term, it's a power of 2. For the third term, it's a power of 4. So you're going to have increasing powers of 2, like n minus 1 powers of 2, n minus 1 powers of 2. As in, when n is 2, I have the first power of 2. When n is 3, I have the second power of 2. N minus 1 powers of 2. And then on the top, it's actually all of that. It's the denominator. I'm going to put den, denominator. It's just the denominator minus 1, right? And then all of that gets times by 3, and it's always to the 1 over, and then it's 1 over, and then it's n minus 1 powers of 2. N minus 1 powers of 2. Okay, so let's look at these individually here. We actually looked at what was happening with the limit of the first part on the previous one. So check that video. I keep mentioning that video. If you haven't looked at 38, look at 38, because I went in more detail there than I probably will in this video. Because I don't want to have every video be super long. If this is going to infinity, then we're essentially going to have 2 to the first power, right? Because if you have 2 to a crazy power, it's going to be like almost, going to infinity, a googolplex, right? 2 to the power of a googolplex. And then in the numerator, it's that value minus 1. So it's essentially 2 to the first power, which would be 2. So the limit as n goes to infinity of a sub n is going to be 2 times, now let's go to the next part. You can split them up a little bit here. So the first part's going to 2. The next part is essentially going to infinity, right? Because it's always going to be 1 in the numerator, and then the bottom is just going to keep getting bigger and bigger and bigger. 1 over a bigger and bigger number is essentially 0, and then anything to the 0 power would be 1. So this one actually also ends up having the same exact answer as the previous one, just because the second part to this limit happened to be 1, and then times by the 2 to get 2. So I mentioned this in the previous video, but let me know in the comments below if you want to see the explicit formula. I've done the explicit formula in a previous video, but I don't remember what video it was. So just let me know if you want to see that, because I'll either go find the video or I'll just like recook and find out what it was that I got for the explicit formula. So yeah, just let me know. But otherwise, go check out the 5 math mistakes everyone makes and how to avoid them. It's on my website, myersmathematics.com, which is down in the description below. And I'll catch you guys in the next video. Blessings, y'all.